Hi everyone, today we're going to take a look at lesson 5-7, roots and zeros. So the first thing we're going to take a look at here is identifying roots, factors, intercepts, and zeros. They kind of all relate to the same topic that we have. So here we have p of x equals a sub n, x to the nth, plus etc. to get to a to the first time x plus a sub 0 will be a polynomial function. Basically, they're saying given a polynomial function, then we have these following statements that are going to be true. That c is a 0 of p of x, which means c is a root or a solution of p of x when it equals 0, and that x minus c is a factor of the polynomial. And then if c is a real number, then c comma 0 is a coordinate point on the graph, which is your x-intercept. So all they're saying here is that given an x value, that if when you plug that value in and you get 0, it's an x-intercept. It's also known as a root. If you write it as x minus c, it's a factor. C comma 0 is going to be a coordinate point, and it's going to exist. So here's an example. Here they gave you x to the fourth plus 2x cubed minus 7x squared minus 8x plus 12. So they're saying there's a 0 here at -3, at -2, 1, and 2. Those are zeros. Those also happen to be roots for when you have p of x equals 0. So those are also our roots. And then we can write these as x plus 3, x plus 2, x minus 1, and x minus 2 as factors. And that we also have the coordinate points -3, 0, -2, 0, 1, 0, and 2, 0 actually exist on that graph, and they are our x-intercepts. And as always, pause the video for if you need more time to write or to read it and to think through it. Pause as needed. So we have the fundamental theorem of algebra, which says every polynomial equation with a degree greater than 0 has at least one root in the set of the complex numbers. So solve x squared plus 2x minus 48 equals 0, state the number and type of root. So we have a couple different type of roots that we'll be going over. So here's our original equation. If it's factorable, great. That makes it a lot easier. So this factors out to x plus 8, x minus 6. And so when we go ahead and use zero product property by setting each factor equal to 0, we find that x equals -8 and x equals 6. Your other option here actually is to go ahead and use the quadratic formula. If you're not that great at factoring, that is another option that you do have. You also have the option of graphing if need be, but we should go ahead and practice those skills for factoring. They will become useful later on in class. So we have two real roots at -8 and 6. That's pretty much, if it's factorable like this, where you can get nice, how you have nice, easy answers, it's going to be two real roots. So here we have y to the fourth minus 256. That is a difference of two squares, which is y squared plus 16 and y squared minus 16. So we can go ahead and factor y squared minus 16, which is another difference of two squares, to get y plus 4 and y minus 4. So by using zero product property, by setting each of those equal to 0, we can go ahead and solve for y. And we get y squared equals -16, y equals -4, and y equals 4. So we get, remember when we take the square root of a negative, we get I. So we get plus or minus 4i. So this means we have two real roots at -4 and 4, and then we have two imaginary roots at 4i and -4i. So that plus minus means that there's two. The other rule is if you have one imaginary root, you have a second. Imaginary roots come in pairs. They do not come alone, they are a set. So if you have one, you must have two when you look at imaginary roots. All right, so go ahead, pause the video and solve for x squared minus x minus 12 equals 0, and state the number and type of roots. All right, so here we can go ahead and actually factor this out. I know 12 would be the same thing as 3 times 4. So I can have this set up here. I just knowing a couple patterns with factoring. Since this has a minus sign at the second one, I know I have a plus sign and a negative sign. Since the first sign is negative, that means the larger number gets the negative side and the smaller number gets the plus sign. So I get x plus 3, x minus 4, and by zero product property, we get x equals negative 3 and x equals 4, which gets us A. You can go ahead and pause the video to solve for A to the 4th minus 81 equals 0. All right, so here we have a difference of two squares. We have A squared minus 9 and A squared plus 9, which gets us another difference of two squares of A plus 3 and A minus 3. And then you have your A squared plus 9. When we set these equal to 0, we get negative 3, 3, and then plus or minus 3i. So my answer would be B, 2 real, 2 imaginary, negative 3, 3, and then 3i, and negative 3i. So a corollary to the fundamental theorem of algebra states a polynomial equation of degree n has exactly n roots in the set of complex numbers, including repeated roots. So a repeated root would be when you have if you graph it, it's easier to see when you graph it, that when you graph it, if the vertex or the turning point is on the x-axis, this point would be counting it as a double root. So even though it only touches once, we would say that, we're going to pretend this is 3. We would say we have x minus 3, and then x minus 3 again would be what we have here. It counts twice if it is a turning point on the x-axis. But for example, if you have a degree 3 polynomial, you have 3 roots. They might be 1 real, you'll have at least 1 real, and then you can have 3 real or 1 real and 2 imaginary. On the 4 roots, you either have all 4 real, you can have 2 real, 2 imaginary, or you can have all imaginary roots. And then 5th power 5, you have at least 1 real root, and then you can have 4 imaginary, you can have 3 real roots and 2 imaginary, or you can have all 5 real roots, meaning that the most it will cross the x-axis or touch the x-axis is 5 times. So we have Descartes' rule signs that will actually help us out in trying to figure out to determine the number of roots that we have. So the number of positive and the number of negative roots. You count the change of signs. The number of times that the sign changes tells you the number of positive roots that you could possibly have. And then you plug in negative x, meaning you just go and change all the odd exponent signs. You switch them, and that will tell you, then you count the signs again, and that will tell you the number of possible negative roots you have. And you always count back from 2. So we'll take a look at that. So we're going to state the number of positive real zeros and number of real zeros negative, and then number imaginary. So we're going to count the signs. So we have a degree 6 polynomial, meaning we have 6 zeros. So we're going to go ahead and do that. So here is p of x. We're going to count the sign change. So negative to positive, that's 1. Positive to negative, that's 2. Negative to negative, we didn't change. And negative to negative, we didn't change. So we had 2 sign changes here. So that means we either have 2 positive real roots or 0 real roots. Now we're going to do p of negative x. So you plug in negative x and simplify, and then you count the sign changes again. I did not have a sign change. Did not have a sign change. We had 1, so that's at least 1 0, a negative 0, and then we had another sign change, so that's 2. So we either have 2 or 0 negative real roots. So just make a list of what's possible to happen. You either have 2 real roots, 2 real positive, 2 real negative, and then you have to have 2 imaginary roots. I can have 0 real roots and still have 2 negative reals, and then that would mean I'd have to have 4 imaginary roots. Same thing if you flip the positive and negative, but then you can also have no real roots whatsoever and be all imaginary. If it's all imaginary, and that is very possible for any even function, that would just mean that it just never touches the x-axis. Or it could just, so we do have quadratics that we typically look at where they just don't touch the x-axis, so they have only imaginary roots. So go ahead and pause the video and then determine how many positive real, negative real, and imaginary zeros you could possibly have for p of x here. All right, so taking a look here for positive, I know I'm always going to have up to 4. So that does help me a couple things because my highest power is 4. So we have 1 change, 2 change, none, none, none. So that means I can have 2 or 0 positive. Very concerned here because I'm looking at some of these answer choices. So then we have, I would go ahead and plug in negative x, so I would get x to the 4th plus x cubed plus x squared minus x plus 3. So no change, no change, yes I have a change, and yes I have a change. So I have 2 or 0 negative. And with that, there is a typo here. This should not be, there shouldn't be a 6 here. There shouldn't be a 6 here. Shouldn't be a 6. This should only be a 4. So there is a typo on this problem. There is. The answer they are looking for is D. But I would have 2 or 0 positive, 2 or 0 negative, and then I can have 4 or 2. There should be a 0 here. You should have 4, 2, or 0 imaginary. Because if I have both 0 and 0, I have to have at least 4. So there is a typo on that question. I am sorry for that. That probably should let them know that they need to go ahead and fix that. All right, so for example 3, we're going to find all the zeros of f of x using synthetic substitution. So the first thing we're going to do is find out how many possible even or possible positive and possible negative. So with this, I have 2 sign changes. So that would mean I have 2 or 0 positive. Go through sign changes, and we have 1 sign change. So I have 1 negative root. So no matter what, I'm going to have at least 1. So it's basically, we have, again, we said we had 2 or 0. We have exactly 1 negative. So these are the options. They went ahead and used when x is -3, x is -2, and x is -1. And this shows the coefficients of the depressed polynomial. And the last column is the remainder. So here we can see our remainder is going to be negative, our x is -1, so 0 as our remainder. So we know x squared minus 2x plus 4. We can use the quadratic formula. And with this right here, I can already tell I have an imaginary root. And we're going to get 1 plus or minus 3, I square root of 3. So we have 1 real at -1, and then 2 imaginary roots at 1 plus I square root of 3, and then 1 minus I square root of 3. And if you can see the graph, you can see that it definitely has only 1 crossing point. A hint that we do have is if the exponent, if your degree is odd, it crosses at least once no matter what. So you will always have at least one root on odd functions. All right, go ahead and pause the video to go ahead and determine the zeros for x cubed minus 3x squared minus 2x plus 4. All right, so you should get A. Is what we have here. So you actually have 3 real roots. You had one negative, you're going to have that, or one positive, and then you have actually all 3 positive, I think is what it ends up being. Yes. No. Yes. Square root of 5. 1 minus square root of 5 would be a negative. So that would count as your negative root right here. All right, complex conjugates theorem. Basically, this kind of goes with what I told you earlier. If we have A and B be real numbers where B does not equal 0, and if you have A plus BI is a 0 of the polynomial function, then A minus BI must also be a 0 of the function. All right, so write a polynomial function of at least degree with integral coefficients, the zeros which include 4 and 4 minus I. So basically, if they told me I have 4 minus I must also know that they have 4 plus I. So we have a couple, they go ahead and let you know that your factors are going to be x minus 4 minus I in parentheses, and then x minus 4 plus I in parentheses. So to get our polynomial function, we are going to go ahead and multiply. I would multiply these two first, so that when we end up doing these, you should notice that we actually have a difference of 2 squares here, which makes it a lot easier once you multiply it out. So we have 4 minus I again, so they even say, hey, this is a difference of 2 squares, so that when we do this, using that pattern we talked about back in 5-5, I can have x minus 4 squared minus I squared. And the reason that makes it just so much easier is, again, this is a perfect square, and then I squared, as a reminder, equals -1, so that helps out. So when we go ahead and multiply that out, we get x squared minus 8x plus 16 minus -1. That simplifies to x squared minus 8x plus 17. So we're now going to go ahead and multiply those two. You can do distributive property, you can do the box, but you're going to multiply it out and simplify by combining like terms. And we get x cubed minus 12x squared plus 49x minus 68 would be my polynomial. All right, so we're going to head, and here is your last example to work out. What is the polynomial with the least degree with roots or zeros of 2 and 1 plus I? Pause the video to go ahead and give yourself a chance to try it. All right, so what we would have here is I would have x minus 2, and then we'd have x minus, in parentheses, 1 plus I. And then I would have x minus, in parentheses, 1 minus I. So again, we would multiply this one out. We would realize that this is a difference of 2 squares. And pretty much what we have, what they do to actually get that is they just move the parentheses around. Since we are only doing addition, we're not actually doing any multiplying yet. So what they do so that they can just say, oh yeah, it's a difference of 2 squares, they rewrite it like this: x minus 1 is a number, and then plus I. And they rewrite this as x minus 1 is a number, and then they have minus I. So now that it does match that pattern, you can go and say, well, that's really just saying x minus 1 squared minus I squared times x minus 2. And again, we're not worrying about that too much yet. So this again, so we can go ahead and x minus 2. X minus 1 squared is going to get me x squared minus 2x plus 1. And then minus I squared gets me minus negative 1, which is plus 1. So we now have x minus 2 times x squared minus 2x plus 2. So I would actually go ahead and do a box for this. I would do x minus 2 and then do x squared minus 2x minus 4 or minus 2. And then just fill it out. So we get x cubed negative 2x squared minus 2x minus 2x squared plus 4x plus 4. Oh, this is a plus. I'm sorry. So this is a plus. So this gets negative 4. So I now have x cubed, and I have minus 4x squared plus 6x minus 4. So my answer is C. That is the end of our lesson, and I will see you guys next time.